here we're going to examine asymptotes and how we can apply limits to asymptotes. So first of all, we're asked to evaluate the following limit by graphing. Now I'm going to just get rid of this f of x part here. We're just trying to evaluate that limit. Don't worry about the f of x. So in order to evaluate the limit, we have to graph 1 over x minus 4. Now we know this is going to look, the parent function is going to be 1 over x, which we know looks something like that. So this is just 1 over x. And that's the parent function. And if we look at the transformation, it looks like it's shifted 4 to the right. And the way I like to think about this is the asymptote here that was at 0 for the parent function gets shifted over to the right and ends up at 4. There we go. So our function, 1 over x minus 4, is going to look something like that. The horizontal asymptote does not change because it's just a horizontal shift, not a vertical shift. So that's still at y equals 0. So this is the function 1 over x minus 4. Okay, so now we're asked to find the limit as x approaches 4. So again, what we have to do is we have to look at as x approaches 4 from the positive side and the negative side. So from the negative side, what's happening as we are approaching this asymptote? Well, if we look at the function looks like it's on its way up, 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 up. And the closer we get to that asymptote, the higher it's going to become. And so the way we put this is that the limit as x approaches 4 from the negative side of 1 over x minus 4, well, what do you think it approaches? It's going to approach positive infinity. Okay, because it's just going to keep getting bigger and bigger and bigger the closer we get to 4. Now let's look at coming from the right-hand side or the positive side. As we're going closer and closer and closer down here to that value, to that asymptote, we're going to be going more and more and more negative. So the way we put that is that the limit as x approaches 4 from the positive side of 1 over x minus 4 is equal to negative infinity. Okay, so does this limit exist? Well, if we look at this, the positive side and the negative side, they are not equal. They approach very different things. Positive infinity and negative infinity are very different things. So we say does not exist. So this is just essentially another way of defining what an asymptote is if we look down here. So we can say a vertical asymptote will exist at c, some value c, so in our case up here it was 4, if the limit of the function approaches positive or negative infinity from the positive side, or as it approaches positive or negative infinity from the negative side, as we saw here. So here we saw that it approached positive infinity from the negative side, and it approached negative infinity from the positive side. So we say that a vertical asymptote is there because the limit approaches infinity from the positive or the negative side. So similar to how we can define vertical asymptotes using limits, we can also define horizontal asymptotes using limits. Because really what horizontal asymptotes are is just what happens to the function as x approaches infinity and negative infinity, the end behavior of the function, right? So we're asked here to find the limit of 1 over x as x approaches positive infinity and negative infinity. So first thing you should ask yourself, can we plug in the limit into the equation? Can we plug in infinity down here into x? Because that's usually how we evaluate limits if we can. The answer is, well, try it. Can you do that? Is there an infinity button on your calculator? Probably not. So we can't treat infinity like a number. We know infinity just basically is a placeholder for a very, very, very large number, and we can't plug in infinity. Instead, let's try sketching a graph of what's going on here. We know that 1 over x is just looks something like this. So we know it as a horizontal asymptote at x equals, or at y equals 0, right? So the question is, what we're saying when we're trying to evaluate this limit, What does the function approach as x approaches infinity? So x gets very, very, very large, right? Well, what do you think this function is going to approach? What's the y value of what it's going to approach? By looking at the graph, you see it's going to get closer and closer and closer to 0. Is it ever going to reach 0? Well, try. Plug in a very, very large number. We can always test this out, right? By plugging in, what if we plugged in f at 1,000,000, right? What's this going to give us? Well, it's going to be 1 over 1,000,000, which is 0.000001, right? That's f at 1,000,000. It's a very, very small number. It's very close to 0. What's going to happen if we plug in a billion or a trillion or a quadrillion? Same thing. It's just going to be a very, very, very small number, and it's getting closer and closer to 0. So essentially what we say is that the limit as this function goes to infinity is 0, because when x is very, very, very large, it's going to approach 0. What happens in the negative case as x approaches negative infinity? Well, similarly here, we're saying basically what happens when this function goes all the way to the left. What does it approach? And you can probably see just by looking at it that it approaches 0 as well. Again, we can test this by plugging in like a very small number, f at negative 1,000,000. And that's going to give us, if we do that on our calculator, it's going to give us negative 0.000001. So a very, very small number, very close to 0 though. So is there any difference between these two limits? Not really, right? Both of these limits seem to approach 0. But the difference between these two limits is that in our positive limit, as x approaches positive infinity, the asymptote, or the function, is approaching that asymptote from the positive side, from above, right? It's coming in close to 0 from above. And we can see that here because this is a positive number. Even though it's a small number, it's a positive number. And on this side, we say that the function is approaching that asymptote from below, right? Because this is a negative number. It's a very small number, very close to 0, but it's a negative number. So we would say that this approaches this from above, right? And over here, we would say this approaches 0 from below. Understanding this will help us sketch these graphs later on. So just to repeat, horizontal asymptotes have to do with the end behavior of a function. And in terms of limits, it's basically whenever the limit of a function as x approaches infinity, positive or negative infinity, approaches a value other than infinity, so a definite value. So let's try some examples. What asymptotes are present in this function here? Let's start off with vertical asymptotes. Where is the vertical asymptote for this function? Well, it's where the denominator is 0, so in this case, the vertical asymptote will just be at x is equal to -1. Easy. How do we find the horizontal asymptotes? And the key here is we're looking for the end behavior. So let's look at where the limit as x approaches infinity, so x is a very large number, of 3x minus 4 over x plus 1. And the question is, how do we evaluate this limit? Can we just plug in x as infinity? Well, no, infinity is not a number, once again. So there's a little trick we can do. I like this trick. We look at the highest degree, and in this case, the highest degree is 1, it's just x. And what we're going to do is we're going to multiply the top and the bottom by 1 over x. So again, we're not changing the value of this limit at all, because we're basically multiplying by 1 over 1, right? 1 over x over 1 over x is just going to be 1. So when we do this and distribute those in, as x approaches infinity, we're basically going to multiply each value by 1 over x. So 3x times 1 over x is going to be 3x over x minus 4 over x over x plus 1 over x. So now let's simplify this a little bit. We see that these two are just going to cancel out and make 1, right? And then we can look at the rest of them like we did on the previous page. And let's look at, for example, oh, and here, sorry, I missed that, these two x's are going to cancel out, and this thing is just going to be equal to 3, right? But let's look at what happens to the other two. So 4 over x. Actually, let's start with the bottom one. This one's a little bit simpler. 1 over x. We said on the previous page, the limit as x goes to infinity of 1 over x, when x gets really, really, really large, this whole term is basically just going to be equal to 0, right? Because it's like you're dividing by a bigger and bigger number. So we can basically say that that is 0. And if we look at the top, it's going to be the same thing with the 4 over x, right? If we're dividing 4 by a very, very large number, it's going to essentially be 0. So we can simplify this as, basically, we've evaluated the limit as 3 minus 0 over 1 plus 0. So essentially what we're saying is that the limit here is equal to 3 over 1, or just 3. So this tells us that our horizontal asymptote is basically going to be at this value, because that's the limit as x approaches infinity. So we can say our horizontal asymptote has an equation of y equals 3. One question for you, if we're approaching negative infinity, right, the limit as x approaches negative infinity, does anything change in what we did in our math? If we look here, look at what we did. All we did was divide by 1 over x, divide by 1 over x. And in the case of here where we cancel these out because x becomes a really, really, really small or large number, which makes the fraction equal to 0, that would happen even if we made x a really, really large negative number, right? They would still approach 0. So nothing actually changes. So essentially what we can say is the limit of the function as x approaches negative infinity is also equal to 3. So that makes sense. Our horizontal asymptote makes sense for as x approaches positive infinity and x approaches negative infinity. One question we also like to ask is about whether it approaches this asymptote from above or from below, but we're actually going to save that for another section on sketching graphs. So now let's look at example B. First of all, are there any vertical asymptotes? Well, if we look at the denominator here, is there any value of x that can make that equal to 0? And the answer is no, there's nothing. Any value, positive or negative, we plug in there is always going to be a positive value because it's going to be squared and then added to 1. So we can say no vertical asymptotes there. Now horizontal asymptotes, let's do the same process as last time. Remember, we're trying to find the limit as x approaches infinity and negative infinity of 4x over x squared plus 1. And the way we do that is we divide everything by the highest power. So what that's going to look like, I'm just going to skip the step where I show that what we multiply by, but essentially we're just going to divide each term by x squared. X squared over x squared and plus 1 over x squared. Okay, so let's look at what happens to each of these terms. We have a 4x over x squared. Well, that 2 is going to cancel, the squared is going to cancel out with the x there, so we're going to end up with 4 over x. And as we saw in the previous example, as x becomes a very, very large number, this essentially is going to go to 0, right? Here in the denominator, these are going to cancel out and we're going to be left with a 1. And here, because we have a very large number to the denominator, this is also going to go to 0. So if we simplify this, essentially what we have is 0 over 1, which tells us that the limit here evaluates as 0. So our horizontal asymptote is going to be at y equals 0. This is a case you can actually come up with a general rule based on this. The idea is whenever the denominator has a larger degree than the numerator, the denominator will always dominate, essentially. And it'll be the thing that goes to infinity, making the whole thing have a horizontal asymptote as 0. Okay? We can also think about what happens when we plug in negative infinity. The same thing is going to happen though, because we didn't actually plug in a negative number here or a positive number here anyways. We just saw that it went to 0, so we'd have the same horizontal asymptote as y equals 0. Okay, question C. So again, let's ask ourselves about vertical asymptotes first. And to do that, we look at the denominator. So if you want, you can stop here, factor it, and find what those values are. Pause here, because I'm just going to show you the answer. So what we get is that our vertical asymptotes should be at x equals 1/2 and x equals 1 if we factor that denominator. Okay, so now let's look for horizontal asymptotes. So we're going to follow the same process here. We're basically taking the function as the limit as x goes to infinity of 5x squared minus 4 over 2x squared minus 3x plus 1. And we look at what our highest power is, and we're going to divide each term by that. In this case, the highest power is squared, x squared. So we will divide each term by that. So 5x squared over x squared minus 4 over x squared all over 2x squared over x squared minus 3x over x squared plus 1 over x squared. Okay, so let's see what happens to each term. Here we're going to have those x squareds cancel out. We're going to be left with just that 5. Here we have a denominator of x squared, so when that gets large, this term is going to go to 0. Here, these x squareds are going to cancel out. We'll be left with 2. Here again, the bottom part here of this 3x over x squared is going to dominate, right? Basically, as the number gets very, very, very large, that denominator is going to get very, very large because it's squared. So this is also going to go to 0. And lastly, 1 over x squared, we already know, again, that goes to 0. So if we want to simplify this, essentially what we're going to end up with in the end is 5. The only terms left are the 5 divided by 2. And again, let's think about what happens as x approaches negative infinity. Well, nothing's going to be different, right? Essentially, those same terms are going to approach 0. So we can say that the horizontal asymptote has a equation of y equals 5 over 2. So last problem for this page, let's look at the vertical asymptote. We know based on the denominator that the vertical asymptote is going to have an equation of x equals -1. And let's find the horizontal asymptote. Same process once again. So we're going to take the limit as x goes to infinity of 2x squared. I'm just going to divide by x squared right off the bat here. So we're going to divide each term by x squared plus 3x over x squared minus 1 over x squared all over x squared. Just skipping some steps here just to save some space on the page. 1 over x squared. So let's look at each of these terms now. So these are going to cancel out. We're left with that 2. This term here is going to go to 0 because that denominator is going to get very, very large compared to the numerator. This term is also going to go to 0 because the denominator is very, very, very large. Same thing with this term, 0. Same thing with this term, 0. So essentially what we have here, as x approaches infinity, this is going to approach, it's going to approach 2 over 0. And the reason why I didn't just put it's equal to 2 over 0 is because this is indeterminate, right? There's a 0 in the denominator. So it doesn't actually equal 2 over 0, it approaches 2 over 0. So as x gets larger and larger, that denominator is going to get closer and closer to 0. So essentially what this means, how this limit's going to be evaluated, is that as that term gets closer and closer to 0 in the denominator, what's going to happen to that whole term? Well, the limit, as this denominator down here gets closer and closer to 0, 2 divided by a very, very, very small number is going to approach infinity, right? Because 2 divided by like 0.000000001 is a large number. So the limit actually evaluates as infinity. So the limit of this as x approaches infinity, actually approaches infinity. And this is a strange case where it's not a definite limit. We don't get a number for it, but we see that what's going to happen is that it's going to approach infinity. So essentially what we're saying is that there is no horizontal asymptote for this case because the limit approaches infinity. It doesn't approach a definite value. So there is no horizontal asymptote. Instead, what we get, which you might remember from advanced functions or previous course, is that we have a slant asymptote or an oblique asymptote in this case. And that occurs when the degree of the numerator is one greater than the degree of the denominator. So here we see that the numerator has a degree of 2, the denominator has a degree of 1. So this gives us an oblique or a slant asymptote, which is different than a horizontal asymptote. So essentially here, we don't have a definite answer. So if this comes up, you know how to evaluate it basically as the limit is equal to infinity.